the ideal gas law in combination with the density equation can give us basically an equation that allows us to calculate the molar mass of a gaseous substance. And so basically you can end up with this equation down here. Now we're going to look at the derivation really quick, and basically it'll give you guys a good idea of how you get this equation. So basically if we take a look at what we have up here, if we look at PV equals nRT, okay, and we take density equals mass divided by volume. Okay, and if we rearrange the density equals mass over volume equation to solve for volume, volume is going to equal mass divided by density. Now, if we go ahead and plug in our volume units, or our units for volume with respect to mass over density, we'll end up with P times M over density is equal to nRT. Okay, if we then cross multiply, we end up with pressure times mass equaling density times N, R, and T. Okay, and then if we rearrange this equation and go ahead and solve for density just by itself, we're going to end up with density being equal to P times mass divided by nRT. Okay, so if we take a look at this, we have our pressure variable, we have our mass variable, we have moles, we have R and T. Okay, so if we look at this equation that we've solved, having mass over moles will give us the same units as we get for molar mass. Okay, because as you know, molar mass is equal to grams per mole. Okay, so we have both of those units present here and in the right position. So we can rewrite this equation to be density equals P times my molar mass and divided by R times T. Okay, and then if we rearrange this equation one more time to solve for our molar mass, we will end up with molar mass being equal to density times R times T, all divided by P. Okay, and so this is the equation that we have right here. So basically you can figure out the molar mass by plugging in your density value, your ideal gas constant, your temperature in Kelvin, and your pressure. Now, when you plug in density in this equation, your density needs to be in grams per liter. The reason why that is the case is because, remember, our ideal gas constant has its units in, one of its units in liters, so that has to be able to cancel out in the appropriate way. Okay, so the problem we have here says a 2.10 liter vessel contains 465 grams of a gas at 1 atm and 27 degrees C. What is the molar mass of the gas? Okay, so let's write out the variables we've been given. We've been given volume, which is 2.10 liters. Okay, we've been given a mass value, which is 4.65 grams. Okay, we've been given a pressure value, which is equal to 1.00 atm. Okay, and we've been given a temperature in 27.0 degrees C. Okay, so we have all of our variables, and we've been asked to solve for molar mass of a gas, and we've been given pressure and temperature and volume measurements, so we know we're going to be using the molar mass equals density times RT over P equation. Okay, so the units that we actually have that can be directly plugged in are pressure, temperature as well, except we need to convert that into Kelvin. So let's go ahead and let's do that really quickly as we're thinking about it. So we're going to add that 273.15 to get 300.15 Kelvin. Okay. R is our ideal gas constant, which is, 0.0821 liters times atm per mole Kelvin. Okay. if we go ahead and now look at the things we do have, as I said, we have R, we have T, we have P, okay, and density we know is equal to mass divided by volume. Well, I have mass and I have volume, so that's going to allow me to calculate for my density. So I'm going to take 4.65 grams and I'm going to divide it by 2.10 liters. Now notice, guys, they've already given us the units in liters. In terms of our volume, so we can just plug that in directly. But remember, for this equation, you need to have your density in grams per liter, so you need to make sure that your units for volume are in liters. So this will give us 2.21 grams per liter. Okay, and then we're going to go ahead and plug it into the equation above. So molar mass is going to equal 2.21 grams per liter times 0.0821 liters times ATM per mole Kelvin times our temperature, which is 300.15 Kelvin. Okay, and then we're going to divide all that out by our pressure value, which is 1.00 ATM. Okay, if we plug this into our calculator, we should get a molar mass of 54.6 grams per mole. Okay, and if we look at the units in terms of cancellation, liters and liters cancel. ATM and ATM cancel. Let's see. Kelvin and Kelvin cancel, so the only thing you have left is grams per mole, and that's what we get for our units for this type of calculation. Okay, so make sure that you're writing out all your variables as usual, that you obviously look at what they're asking you to solve for, apply the appropriate equation, make sure that your units for temperature are in Kelvin. In addition, make sure that your density value, the volume portion, is in liters, and do your calculations and subsequently plug your numbers in and do the math.